So when multiplying radicals, you don't need to find like radicands like you do adding and subtracting. You can just multiply straight through. So if I had a front number in front of this 2, then I would multiply that and that, but I don't have any, so I'm just going to look at the insides, and I have a 2 and an 8. So that's going to stay inside of the radicand, so 2 times 8 is 16, and then I reduce that further. I know that it's a perfect square, so I don't have to do my factor tree. I just know that 4 times 4 gives me 16, so those two would pair up and come outside of the house, and I don't have anything inside of my radicand. This one, it does have numbers in front, so you'll just multiply those together. So that would be 3 times 4 is going to give you 12, and then I'm going to multiply the insides of the radicand, and it's going to give me 10 times 10, which is 100. And then I would simplify 100, and I like 100 because I know that it's a perfect square, and I know 10 times 10 makes 100, so therefore 10 is going to come out of the house, but I have this original 12 here, so we're going to multiply the two together to give me 10 times 12 for a final answer of 120 on that one. Take a look at the last one. I've got 2 times 3, which is going to give me 6, and then 3 times 15, which is going to give me radical 45. So I go to my calculator and I type in y is equal to 45 divided by x, and the y equals area in the top left-hand corner, and then I'm going to do second graph to get my table of values. And I see that 1 and 45 might work, 3 and 15, 5 and 9. I'm going to stop at 5 and 9 because I like 9 because it's a perfect square. And I know that 3 and 3 would give me 9, so I know a 3 is going to come on the outside, and the 5 is left over. So I still have to multiply what's on the outside, the 3 and the 6, so that leaves me with 18 radical 5, because the 5 did not pair up, didn't get a roommate, or didn't get married, so he had to stay inside of his parents' house.